Hey everybody, this is Mr. Chernetsky, and this is our quarter four final review. So let's go through each problem. First problem, circle below is divided into sectors. Segment EB is the diameter. The radius of the circle is 3. Calculate the arc length based on the corresponding central angle. So, if we looked at the first central angle, AFB, that is this angle. So arc length in degrees is going to be 120 degrees. BFC is that arc there. That's 45 degree central angle, so it's a 45 degree arc. CFD, 30 degree central angle, so 30 degree arc. Let's put these other ones up here. And then the last one, AFE. Well, we know EB is a diameter. That means that from E to B is 180. So this semicircle is 180 degrees, and 120 of it is already taken up going from A to B. So if we want this other chunk, we're going to take 180. Let's keep the same colors. 180 minus 120, which is going to give us our angle we're looking for, which is 60. And there we go. All right, question 2. Segments WZ and XR are diameters. Calculate the measure of ZWX. So we're going ZWX, so all of that. Well, one easy way to figure this out is recognize that WZ is a diameter. So from here to here, all of that is 180. Then we also have this 49 degree angle here. So to get from Z all the way to X, we're just going to add those two, 49 plus 180, which is going to give us 229 degrees. Moving on. Write the standard equation for a circle with a center of 2, 4 and a radius of 3. So our equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared, where h and k are the coordinates of our center, r is the radius. So we really just plug in 2 and 4 into this equation. So x minus 2 quantity squared plus y minus 4 quantity squared equals 3 squared, which is 9. What are the possible names for the quadrilateral pictured below? So, well, it's most definitely, at the most basic level, it's a parallelogram, because we have opposite sides are equal. It is a rectangle, because we have all four angles are 90 degrees. It is a rhombus because all the sides are equal, but the most specific one, it is a square. Classify the quadrilateral below. We have all four sides equal, so it's a rhombus, but that is also a subcategory of a parallelogram. The best description would be the rhombus because that's the most specific description. Just like in number 4, the best description would be a square. ABCD is a parallelogram. Draw the diagram below. Name the congruent angles, then name the supplementary angles. Okay, so we'll go ahead and draw a parallelogram. It's A, B, C, D. It's a parallelogram, so we'll go ahead and draw 2 sets of parallel lines. The congruent angles are going to be the angles across from each other, so A is going to be congruent to C. I should use the angle symbol. Angle A is congruent to angle C. Angle D is going to be congruent to angle B. So that's the first part. The supplementary angles, well, all the angles that are next to each other. So A plus B is going to equal 180, B plus C is going to equal 180, C plus D, and D plus A. So we'll go ahead and write those out. So A plus B is going to equal 180, B plus C is going to equal 180, C plus D is going to equal 180, and D plus A is going to equal 180. Number 7, find arc length. Okay, we'll use our arc length formula. So we do our central angle over 360 times the circumference of the circle, which is pi, 2 times pi times the radius, 2 pi r. So we'll go ahead and do that. 60 divided by 360 times 2 times pi times 9. Get approximately 9.42. Find the sector area. Okay. Almost the same formula. We do 80 over 360, or central angle over 360. But instead of 2 pi r, it's times this area of our circle, which is pi radius squared. It's 80 times pi times 4 squared. And we get 11.17 approximate. This one actually gives us units, so we'll use the proper units. Square units, or square feet. Calculate the volume of the cylinder. Volume is pi r squared h for cylinder, so that's going to be equal to pi times 9 squared times 15. I'm going to keep it in terms of pi first, so that's going to be 9 squared is going to be 81 times 15 gives us 1215 pi, which is approximately 3817.04. Cubic inches. Calculate the volume of the pyramid. It's got a length and width of 11 by 11, and then a height is also 11. So 11 by 11 base, square base, and then it's got a height of 11. So our formula for volume of a pyramid: 1/3 area of the base times the height. So that's going to be volume equal to 1/3 area of our base, 11 by 11 is 121 times our height, which is 11. So plug that into the calculator. 1/3 times 121 times 11, and we get 443.67. And that's going to be cubic centimeters. Volume of the cone. Volume of the cone is equal to 1/3 pi r squared h, so 1/3 volume of a cylinder. So we'll plug in our values: 1/3 pi 21 squared times the height, which is 36. Times 21 squared times 36, which gives us 16,625.31 cubic centimeters. Calculate the volume of a sphere with a radius of 24 inches. Volume of a sphere is 4/3 pi radius cubed. So we have our radius there is 24, so volume equals 4/3 pi times 24 to the third power. And 57,905 .84 cubic inches, and that's approximation since we rounded. Okay. A prism is quadrupled in dimensions. How much bigger is the surface area? So remember, surface area scales by your, or increases by your scale to the second power. So since we quadrupled, our scale is 4. 4 to the second power equals 16. So it got 16 times bigger. Okay. If our prism is quadrupled, how much bigger is the volume? Remember, in volume, our scale increases by the third power. So this would be 4 to the third power, or 4 times 4 times 4, which is 64 times bigger. So you make a prism and you quadruple it in size, you get 16 times more surface area, even though it's only 4 times as big, and you get 64 times the amount of volume. So surface area grows more than your dimensions, but your volume grows even more than that. So, all right, that's the end of this review. Good luck on your final.